So thank you all very much for joining the session. My name is Chad Sweet. I'm the CEO of ModalAI. We're located in San Diego, California, and happy to talk to you about what we are doing with PX4, open source, and 5G drones. So we're actually currently working on the 5th generation of Snapdragon-based companion computer, flight controller, autopilot, what have you. And we started working on this in 2015 at Qualcomm. We had an internal program, then we created a product called Snapdragon Flight. This was a Linux-based SBC or single board computer that performed PX4 mainline inside of the DSP on the Snapdragon. That platform ended up, I don't think it flew PX4, but it ended up on the Mars helicopter, Ingenuity helicopter, currently out flying missions periodically on Mars. We evolved that to Qualcomm Flight Pro. There was a slight branding name, which then in 2018, ModalAI was created, and we started evolving the Qualcomm Flight Pro into a product we call Voxel, spelled VOXL. So the Qualcomm Flight Pro was built around a more advanced processor that was then evolved into what became Voxel Flight, which fused what you might think of as a Pixhawk into the same PCB as the companion computer built around Snapdragon. And we've just announced in collaboration with within the last few weeks, what's referred to as the Qualcomm Flight RB5 5G. And this is now built around an incredibly state-of-the-art, blazing fast Snapdragon processor, the 865, or in the robotics domain referred to as the QRB 5165. And this chipset, 8-core, tons of AI processing, and we've fused that with a 5G modem. So this is a ready-to-fly 5G drone. And our goal when building out this, and as we work with Qualcomm, is really to make this technology accessible to really the next generation of enterprise developers, building all of the great use cases that we've been talking about today at the conference and hearing about, I'm sure, over the next day as well. And so we try to provide the entire stack, or we do provide the entire stack from what we call Flight Core, which is a mainline PX4 FMU V5X derived flight controller built in the US. We have Voxel. We can take those two, we can fuse them. They can be separate. They can be fused as Voxel Flight. We then have what we refer to as a flight deck, which builds upon that, which has 4 image sensors built in, 3 for computer vision, 1 for RGB video. Then that's referred to as the flight deck that we mount onto an actual UAV we call the M500. And so we have all these levels of integration points for OEMs and our customers to take and build new applications. And they're very diverse. We have a lot of customers doing a lot of very, very diverse and sometimes seemingly random applications, but we love that. And we make all of the code available at code.modalai.com, and our documentation is actually openly editable, and it is available at docs.modalai.com. And so encourage you to check that out. And so what you see here is a typical stack of components that might go into your average enterprise drone. And we try and fuse that by enabling our customers to build smaller, smarter, and safer UAVs. The functionality that we provide, especially in the flight deck or so, is what you may think of as a Intel RealSense paired with a Jetson Nano, paired with a Pixhawk, paired with the Mango LTE radio or 5G radio, Mango board. We put them all in one, make it available. Swap size, weight, and power is very important when you're fighting gravity. So our goal is really to help customers get to that next use case and build out the next great technology. And so 5G, what is 5G? It's really rather straightforward. It's the 5th generation of cellular technology. A lot of us having, very deep roots at Qualcomm, and Qualcomm leads the effort in 5G, and they had, of course, in 4G and 3G. A lot of us have worked on these technologies at a very deep and fundamental level. I personally was one of the first 35 folks to work on 3G data back in 1999. And our head of software worked on, I believe, as far back as 2G digital communications. And so we've seen this evolution from the inside, and are very excited to see what's going to happen with 5G, which is often not, each generation increases the capability. Often, you can just think of it as reduced latency and improved bandwidth, but it's what happens with that, you don't quite know. Anecdotally, when we first deployed commercially 3G data in the year 2000, we spent the next 6 years trying to figure out what to do with it. And not until the iPhone was released was it even really obvious what one would do with mobile data. There were 6 years where folks didn't even think it was necessary. Now, of course, nobody can live without it. So it's definitely going to be interesting to see what happens with 5G. And so obviously these are the use cases everybody knows for enterprise UAVs, and these 5G was designed with mission critical applications in mind. So meaning low latency, high reliability. Those facilities are built right into the standard and into the deployments. And so, for autonomous cars, autonomous drones, autonomous robots, making sure everything's truly connected, kind of building on what you saw a glimpse of with LTE and 4G, and the ability to have a remote node on the internet, a mobile node on the internet. Now it's really built in or baked in to be a critical part of the infrastructure being deployed right now and today. And so some of the exciting capabilities will be private networks, the ability to have multiple UAVs on the same network, that then starting to, multiply the effectiveness of each pilot out in the field with minimal radio deconfliction. These systems are designed to have multiple radios sitting right next to each other. And so there you won't run into frequency collisions and so forth. And of course, the range will be as far as the cellular network can take you. And actually coverage gets better when you're in the air. So it's better in the air than on the ground. So the platform we've built to highlight this has been done in collaboration with Qualcomm. This, of course, is built around PX4 as the main flight controller. We're actually back to running the PX4 flight controller on the DSP, on the Snapdragon processor in this system. So that's been both challenging and cool, and we hope to mainline that this year. That's the goal. That's all. The implementation we have is actually all public. If anybody's interested, we can show the branch and so forth. But it comes with visual inertial odometry fused in, obstacle avoidance, the PX4 collision prevention, and a 5G modem, the ability to connect right to the internet, and of course, lots of computer vision. This has 15 TOPS, or trillion operations per second, of deep learning capability in real time. So this is like what you might think of as NVIDIA Xavier class processing on a much lighter, lower power, flyable platform. And so that's up now for pre-order, and we're hopefully shipping in the next few weeks. Those first orders, of course, in the order that they come in. And what you see on the left is what we refer to as the 5G flight deck, or the RB5 flight deck. And inside of there, inside the little case, is the 5G modem. And when you're connected, you're a node on the internet. You just see, we're running Ubuntu, and so you can see the WLAN interface, and you communicate that way. I'll show a little demo here of what that looks like. Oops.
Hi, this is Rich from ModalAI. We're flight down here testing our 5G RB5 drone. This is
so muting the volume there, but yeah. So we have a fully connected system. The laptop is running Q ground control, connected over 5G, and of course the UAV itself is has that 5G modem we were showing. And we get up here. I'm going to fast forward just to move quick into questions. The flight is originally being manually flown through the joystick connected to the laptop through ground control, running Mavlink, sending Mavlink commands, and doing manual flight. So the UAV is flying manually like you would normally. The response is very good. The latency is very low latency. You can, fly, and it feels fairly normal. And so then we move into the mission phase and set up a normal waypoint mission, configure VIQ ground control, send the commands over to the flight controller running those commands are sent over 5G, deployed, get the confirmations and so forth. And then the UAV goes and executes its mission. And so fairly straightforward, all integrated and built in and fairly ready to go. Of course, this will all have code that's pushed, open, and available, and for for developers to take, modify, extend, contribute back. The documentation has started to pop up already on docs.modalai.com, and so we expect all of this, this to be an evolving, living development platform that we're supporting for years to come. Let's see if I can get out of the video. And that is it. So let's see. I think there are a few questions. And let's see. So yeah, is there a plan to integrate iPhone LiDAR with the solution? Well, oh wait, this might not be the Q&A for this one. So we'll see if there's any chat. But otherwise, if anybody has any questions, feel free to post them in the Q&A session. Well, I'll just assume these are for us, but any plan to integrate iPhone LiDAR with the solution? Not specifically iPhone, but we do work with PMD on time of flight, and that ultimately will be integrated into the solution. We don't have it at launch, but that's something that we plan on doing. And then also Ethernet support for IP cameras. Yeah, through USB to Ethernet, but it works well, and we use that in a lot of ways. And sometimes we even do chip down implementations of that to communicate directly with Ethernet cameras. And so there's a lot of USB. There's USB 3 expansion. There's a USB 3 hub on board the RB5 5G drone platform, so you can plug in multiple payloads, really, many different types of webcams and cameras, and lots of things come in over USB 3 very efficiently and quickly. So feel free to post. I think we have 1 more minute if there's any more questions. Okay, actually, I am not seeing the same questions, but I'm getting let known that there are questions, so I'll try and answer those quickly. What is the interface between the flight controller and Snapdragon computer? So they're all integrated in one. It's actually, right now, it's UORB, which is the same interface that runs internally to the flight controller. And how does integration expansion with NVIDIA Xavier AGV work? Well, this would be a comparable and competing product. So it's the same level of horsepower and so forth as the Jetson. The Voxel internal GNSS, we generally recommend using an external GNSS. There is on the Voxel an internal GNSS that performs pretty well. It's just tricky to use because it's an RF interface as opposed to digital. So we tend to recommend using like a U-Blox typical GNSS system. So thank you all very much. Okay, now I found the right questions. Took a while. What operating system runs on the Snapdragon? Ubuntu. How much interference do you expect with a swarm of drones communicating over 5G? It's designed to do that. None, really. I mean, the system's multiple access, and it's designed to do many, you know, a lot, like many dozens or hundreds, depending on, of course, how much bandwidth you're trying to push. All right. Thank you, everybody. I'll head over to the ModalAI booth.